Greetings, my name is Mike and welcome to the Beginner's Guide to Hilt. Now this video assumes you know nothing about Dagger or Hilt at all, so it's going to be completely, as it's called, Beginner's Guide. And there will be a list of timestamps below for all the stuff I'm going to talk about, so do check it out if you're interested. Now Hilt is a dependency injection library built for Android. Dependency injection is, simply put, a technique where when you're constructing an object, like a repository for example, you will pass in the other objects that it depends on, like caches and services and whatever that might be. So let's have a look at how to set up the project. In your top level build.gradle file, add a class path dependency and make sure to check the website for the latest Dagger version. Then in the app level build.gradle, apply the Hilt plugin. And if you're using Kotlin, make sure you also have Kotlin capped applied. Next, we'll just add a normal implementation dependency. And finally, if you're using Kotlin, add a capped dependency. And if you just have Java, add an annotation processor dependency. The last bit of setup to do is to just annotate the application class with Hilt Android app. And of course, if you don't already have an application class, just create one and don't forget to add it to the manifest. Alright, now that you're all set up, let's have a look at some sample code. I've got this project that's available on GitHub if you're interested, so let's have a look. You can see there's a few sections I'm going to be talking about, but we'll be starting with the basics one. When you open it up, it just downloads a list of beers from a free API and shows it on the screen. That's pretty much all. But behind the scenes, let's have a look at what's going on. I've got an activity, and a view model, and a repo class. So let's start by looking at the repo class, and you can see that I've already implemented dependency injection. I have three constructor parameters, a service, a cache, and coroutine dispatcher. And here I have a convenience constructor which has no parameters and will instantiate them accordingly. So how can we add Dagger support here? How can we ask Hilt to create these dependencies for us? Well, the easiest way is to add a constructor that's annotated with inject, like so. This will tell Dagger that whenever it needs to create this repo class, it must use this constructor. And any parameters that it has must also be created by Dagger. What I'm going to do now is just go to the view model and also create an inject constructor. I'm going to come back to view models in a bit, so don't worry too much about this. And I'll also make it a Hilt view model. And finally, in the activity, I will annotate with Android entry point. But again, I'll be coming back to that soon, so don't worry about it. Now I'm going to try and build the project and we will see what happens. We get quite a lot of red here, but don't worry about it because it actually tells you exactly what's wrong. You'll see it starts off by saying that the beer service cannot be provided without an @provides annotated method. And then there are similar errors for the beer cache and the coroutine dispatcher. So what this is saying is just Hilt doesn't know how to construct these dependencies, so it fails at build time. Now the simplest way to fix this would be to go to each of these and annotate them, or annotate a constructor with inject like we did here. However, it's not always going to be possible. The beer service, for example, is a retrofit interface, so you can't add a constructor there. The cache is just a Kotlin object, that you can't add a constructor to it. And finally, the coroutine dispatcher is part of the coroutines library, so I can't change that code even if I wanted to. But luckily, Dagger has a way to help us with this. It has a concept of modules, and that is a class that we annotate with module. And also install in is required, but I'll get back to this later. Don't worry about it for now. So I'm going to start by creating just a companion object so I can write methods with bodies. And I'm going to make a method that is called provide beer service, which returns the beer service, which is what we're injecting into the repo. Now you'll notice it's got a provides annotation, which is telling Dagger that this method is going to be a method that we can use to satisfy the dependency, the beer service. Then in the body, I'm just going to copy the retrofit code from the repo. And that's all. You just construct the dependency as you would normally. Now I will try and build the project, and it will still fail, but for a different reason now. You can see that it still complains about the beer cache and the coroutine dispatcher, If I can see it, there it is. But now not about the service anymore because we have satisfied that dependency, which is great news because we're making progress. So I will just add provides methods for the other two cases. The cache, return via cache, since it's an object, I can do that. And the coroutine dispatcher. And I will return dispatchers.io. Don't worry if you don't know coroutines, it has no effect on this video at all. And now I've satisfied each of those dependencies, so if I try and build, we should get a successful one. Build successful, so that is awesome. We are now providing all three dependencies to the repository. So I'm going to do a bit of cleanup. I'm going to get rid of the convenience constructor that I had before, because Dagger is now setting those for us. And in the view model, I also had a convenience constructor that I can get rid of, and we are all set. Now I'm going to build and run, and just make sure that the screen still behaves as it should. There we go, installing the app. And when I navigate to the sample, it still loads, no crashes, and everything is good. So that's great. We have implemented the most basic version of dependency injection with Dagger, which is annotating a constructor with inject and using a module to satisfy dependencies. Now, before I move on to the next topic, I want to just mention something about interfaces. And generally, it's good to program against interfaces. So I would have one for my beer repository here. I would implement it, of course, and then I will just add the method to the interface as well. Then in the view model, I will, of course, want to depend on the interface instead. However, if I try to build this, we will get the familiar error saying that the beer repository is not provided. The interface cannot be provided. And that kind of makes sense because we haven't told Hilt anything about this interface at all. So it just kind of fails because it doesn't know. Now, you might think that a good way to do it would be to add a provides method. So let's do it. And the return type now is the interface because that's what we will be injecting. And we will return just a new instance of the implementation. But of course now we need to pass in these three parameters, which are the dependencies of the repo. Luckily with provides methods, you can add parameters that are objects which are provided by Dagger. So we have the beer service, which I'll add, the beer cache, and the coroutine dispatcher as well. Then I'll just pass each of them to the constructor. Pretty straightforward, and it's a very nice feature that Dagger has, adding parameters to provides methods. Of course, if you add something here that Dagger doesn't know about, it will fail, saying that it is not provided. And let me just build this, but this does work because we are now providing the interface. However, it's not, in my opinion, the neatest way to go about it. There you go, the build was indeed successful. What you can do with interfaces is you can write actually an abstract method, and I'll call it bind beer repository. Again, it will return the interface, and now we annotate it with binds instead of provides. And you need to add a one parameter, which is the type of the implementation class, like so. And also just make sure that the implementation class has an inject constructor on it. But what this is doing is it's telling Dagger that whenever someone requests the beer repository interface to be injected, go and create this implementation class for them. Pretty straightforward. And that is basically what is happening in this provides method. So I can just remove it now and build and run the app, and we should be all good. Just got my coffee to keep me going. There we go, build and run, and we indeed can get to that activity without any issues. There you go. So in my opinion, I think you should try to use the binds approach when you can, when you have an interface and an implementation. It won't always be possible, of course, like what we saw below, but in most cases you should be able to use this. Alright, now I want to just go back and talk about Android classes. So I'll open up the activity here, but classes like activities, fragments, views, and services, we can't add constructor parameters to them because we are not instantiating those classes, it's the system that's doing it, so you'll just have horrible problems if you try to add parameters. But since Hilt is built for Android, we of course have a way to go around this. What you'll do is annotate it with Android entry point, and this applies to activities, fragments, views, and service classes. Annotate them accordingly, and then instead of adding constructor parameters, you can just add inject fields. So for example, I could inject my repo here, and please don't do that, but just for an example, this is what you could do. Then Hilt will set this field for you when super.onCreate is called, so after that point you can then go and use it and you'll be all sorted. And again, this will be very similar for fragments, views, and service classes. Now the view model is a little bit different. We can fortunately have constructor parameters, and you'll just have to annotate it with Hilt view model. Then you're all good to go. Then how you'll instantiate it is in the activity or the fragment. You can just use by view models in Kotlin, so this very nice syntax. Or in Java, you would have to say view model provider, pass it the activity or fragment, .get, and then the class of the view model. That's how you would do it in Java, but I much prefer the Kotlin one, to be honest. And then that's all you need to do. Hilt will be providing this view model instance for you, and then you can go and do what you need with it. Pretty awesome, and I think Hilt makes it very simple to do. Alright, next I want to just go back to this module that we were looking at earlier. Now, when we create methods inside of here, we are creating what we call Dagger bindings. So for each of these methods, we've defined a binding. Here we have a beer repository binding, beer service binding, and so on. That's just a term that I want to lay out, is a Dagger binding. Now, I also glanced over this install in annotation earlier, and it's actually pretty important to understand what's going on here. This is saying that we want to install all of these bindings into the singleton component. Now, a component is a concept in Hilt that is pretty much a collection of dependencies. Right, so we are adding all of these dependencies, or all of the bindings, to the singleton component. And there are a few different built-in components in Hilt. If you see this diagram from their website, all the components are on the left-hand side. You have things like the singleton component, activity and fragment, and so on and so forth. And then on the right-hand side, you can see an Android class, like the application or an activity or fragment. And each of these components is associated with an Android class. What does that mean? Well, each of the components is tied to the lifecycle of their corresponding Android class. So if you have a look at this poor diagram that I made, the singleton component is created when the app starts and is destroyed when the app finishes. Pretty straightforward. So there's only one singleton component throughout the whole app, hence the name singleton. However, when an activity is started up, an activity component is created which has a reference to that activity instance. And then when that activity is destroyed, so is the component destroyed. And it's very similar for other things like fragments and views. Right? The component has a reference to the Android class that it's associated with. But I'm going to show you some code examples soon to help illustrate this, so don't worry too much. Now, components in Hilt also have parent-child relationships. As you can see, the singleton component pretty much sits on top of all the others, and the other components will end up extending from the singleton component. Now, inheritance between these components just means that any bindings that are installed into a parent component will be available in children component as well, but not the other way around. Components also have default bindings that are available to them that are provided by Hilt. For example, you can see that the singleton component has the application context as a binding. So that means you can inject the application context anywhere that you need it. And similarly, the activity component has a reference to the current activity instance that it's associated with. So then you can inject the activity instance into classes that depend on an activity. And it's very similar for the other things like fragments and views and services. So let's just have a look at some code to help explain this a bit more. Just going to open up a different sample here. Here is some pseudo-code that I've written. Please don't think much of this other than pseudocode for demo purposes, but this is how one could represent the singleton component. It is a class that has a reference to the application context. As I mentioned, it's a default binding. And if you were to install a binding in the singleton component, it could look like this, where you have a method that returns something like an application monitor, which needs the application context. So you can just create it like that. Then you have something called an activity retained component. Don't worry about it. But importantly, it extends from the singleton component. And the activity component extends from activity retained component. Now, if you know from inheritance, when you inherit a class, you get all of its methods and properties as well. And that is true here. So within the activity component, we also have reference to the application context. Now, activity component is also associated with an activity instance, so we get that as well. And you can use it to create dependencies, to instantiate dependencies that would depend on an activity instance. And very similarly, the fragment component extends the activity component, so it gets access to all of the bindings like the application context and the activity context. And of course, it's associated with a fragment instance as well, which you can use. So I don't know if this helps to explain the concept. For me, it's good to see code and to help visualize it a bit. But maybe this does help. Anyway, let's look at some code that is actually used in the demo app. Here I have three modules which are installed into different components. I have a singleton, activity, and fragment. Sorry. So I also have three classes at the bottom. Each of them depend on different things. We have an application context, an activity context, and a fragment context. So how can I provide each of these with Hilt? How can I add bindings for each of these? Well, I'll start in the singleton one, because that's what we've been working with so far. I'll make a provides method for the app monitor class. Monitor, if I can spell it. And then we'll just return a new instance. Now, if you remember from this diagram, there's a default binding available, which is the application context. So I can add it as a parameter here, and then pass it to the app monitor like so. Next up, I want to try and add one for the activity monitor, like so. So we'll just return a new activity monitor instance. And of course that needs the activity context as well. And I'll just pass it along. However, this is not going to work because these are being installed into the singleton component, which does not have access to the activity context. If you remember from this diagram, the activity component is what has access to the activity context. So therefore, I would have to move this binding into the activity module, which is installed into the activity component. A lot of words going on, but I think it makes sense. At least for me, it's a good way to visualize it. And similarly, for the fragment monitor, we will just add a method in the fragment component. What are you doing? Why are you showing weird text? And we can add a fragment as a dependency because the fragment instance is a binding available in the fragment component. So this will all work out fine now. And if I go to my sample activity here, I'll add an inject field for the application monitor like that. And I'll add one for the activity monitor and for the fragment monitor like so. However, if I try to build this, you'll see that it actually fails. It tells me that the fragment monitor cannot be provided, even though we have the provides method for it. And that's because we're trying to inject it into an activity, which of course it's not a fragment, so it doesn't make sense here. We installed the binding into a fragment component. So therefore we would have to move it into a fragment for it to be able to work. And if I build this as it is, it will work fine. There you go, it builds without any issues. So hopefully that kind of makes sense to visualize or make it a bit more practical for what the components are there for. But simply put, most of the time you'll install stuff into the singleton component. Classes that do not depend on an activity or a fragment can just go into the singleton component, and then they'll be available anywhere. Now, if you add stuff to the activity component, they can only be injected into an activity, which makes sense because they need an activity instance. So just keep that in mind. Alright, let's move on to some more topics now, and I want to talk about qualifiers. Qualifiers are a concept in Dagger that allow you to distinguish between two different cases of the same object type. So let's just see what I mean here. So I have a phone object, which I'll just make a provides method for. And let's say the model is a OnePlus. Alright, and I want to make it actually called provide Android phone. Then I'll add another method that's an iOS phone. And let's say the model is iPhone 12. I don't know what iPhone models there are. So say you want to do something like this, where you have two different cases of the same object here. Now, if you were to try and inject this, a phone object, the build will fail, and rightfully so, because there's some ambiguation going on here. It doesn't know which phone you're referring to, which binding should it use. If it can hurry up and fail already. There you go. And it tells you that phone is bound multiple times, and it points to the provides methods, which is quite nice. And I mean, this makes sense because, which one does it use? So here is where qualifiers come in. The most simple qualifier is named, so you can add an annotation, and then it just takes a string that's going to be unique to this binding. And I will add a different one for the iOS binding. Then when you use it in the activity, you also need to add the named annotation. Let's say I want to add the Android one. And I'll just add a text label, not a button, which displays the phone's model so we can see it's indeed working. Now I'll go and build and run the app, and we can see the qualifier sample in action. Here we go, qualifiers, and you can see it does indeed print out the Android one. And of course, if I change it to iOS and rerun, it's now going to change to the iPhone 12. And I go to qualifiers, and indeed it has changed. So that's the most basic use of qualifiers. You can use the built-in named annotation to distinguish them. However, I don't really like it, to be honest, because you now have these magical strings floating around. So what you can also do is you can write your own annotation, your own qualifier annotation that's annotated with qualifier. And I'll add another one for iOS. Now you can use those instead of the named ones, which I think to me is a bit more readable and maintainable. And of course, in the activity, you would need to change it here as well. Now if I build and run this, we will see that it's changed back to the Android phone. And there you go, it's back to a OnePlus. So that is the power of qualifiers, being able to distinguish between different types of the same object. And of course you can have as many different qualifiers as you need. And just a note about my sample app here, you'll see I'm injecting it into an activity just for demo purposes. But the same would apply to something like any other class. If I had a qualifiers view model, which extended a view model, and you would of course need to have a inject constructor on it. Now the same would apply if you want to add a dependency here. Instead of just saying phone like that, you would need to add the qualifier to it as well. So that's how you would do it in a constructor parameter, and as a field you would just add it like that as well. Pretty straightforward. And I'm going to be doing this for the rest of the demo, so just keep in mind that it works pretty much the same on a constructor parameter. Alright, so that's pretty much all there is that I wanted to show for qualifiers. The next topic is quite an important one, which is scopes. Now scopes are also annotations, but they are used to extend the lifespan of objects that are created by Hilt. Let's just have an example here. So I'll write a provides method again. this time for a jetpack object, which I have below. I'll call a constructor, and this time we are going to be passing in just a serial number. So I'm going to be keeping track of how many instances we have created. Start off on 0. Then when I call a constructor, I will increment the serial number. In the activity, I will just inject a jetpack instance. Actually, I'll make it 2 of them, just so we can see easily in the demo. Then I'll add a column to display them with a text label. We'll make the text jetpack number, and then jetpack 1 dot serial number, and then just duplicate it for the second one. So let's just build and run this, and the expected behavior is that it's going to say jetpack number 1 and then jetpack number 2, right? Because we have 2 instances being created here, which is the serial number there. So I open it up, and you see now we have number 1 and 2 being created. If I go back to the activity again, we now get 3 and 4, because it's a new instance each time we inject it. Pretty straightforward, I think, and this is what we call unscoped bindings. We have no scope annotations here, so it returns a new one each time. This will be fine in most cases, I think, but sometimes you will want to extend the lifespan of this object. The simplest and most common scope annotation is probably singleton. And as the name suggests, it will reuse one instance of Jetpack throughout the whole application's lifecycle. So now if I go back to scopes, we see it's Jetpack number 1 always, no matter how many times I go back to that activity. It's just using the same instance. Just keep in mind though that of course you can still call this constructor manually yourself from anywhere, and you'll have multiple instances. It's only from a Hilt point of view that there will be one instance available. Alright, but you can also do other things like scope it to an activity instance. So for example, I'll use activity scoped over here, and I also need to now install it in the activity component because the scope annotation is tied to the component. And as you can see here, each component has their own scope annotation that you can use. But I'll just rerun this app now with no changes to the activity, and we'll see some slightly different behavior. When I go back to scopes, we can see it's 1 and 1 as it was with the singleton, but when we recreate the activity now, we get a new instance. Because we have scoped the Jetpack instance to that activity's lifetime. So when the activity is destroyed, of course, and come back, we will get a new Jetpack instance. Hopefully that kind of makes sense. And the similar will be true for things like fragment scoped or view scoped or view model scoped even. It will reuse the same instance for that whole lifetime of that specific class. Alright, so that's all I wanted to show off for scopes. Just another side note though is that the documentation recommends using scopes only when it's necessary, because it has an effect on the generated code size and runtime performance. So you should only use these scope annotations when it's necessary for correctness of your code. Like if you want a singleton, then by all means annotate it accordingly, but don't go annotating everything as activity scoped just for the fun of it, because it's going to negatively impact the performance a little bit. So just something to keep in mind. Next up is a fairly more lightweight kind of topic, and that is a lazy injection concept. So I'll just start off by writing a provides method as we've always done, which returns a car object. And we'll just make it Mazda because they're awesome. And I'm also going to keep track again of how many we have created. If I can press the right buttons. And then when I create it, I will just increment that number. Then in the activity, I will just go and inject it like we always have. Now what's happening here is this is non-lazy injection. When the activity starts up, it will create this car instance straight away, so it's ready to be used. But in some cases, that might not be what you want, because it might be expensive to instantiate and you might not use it every single time. And in that case, you can make it lazy. And just make sure you import the Dagger lazy over here. Then you just wrap that object in the lazy instance. Now what's going to happen is when the activity starts up, it will not create that car object immediately. What you have to do is, I'll just add another text here. So let's just print out the car.get. That's what you use on the lazy. And then we'll print out the make. And I'll just add a few more for demo purposes. So once you call get for the first time, it will go and instantiate that car object and then hold on to it for the whole life cycle of the activity. So let's run the sample and see what happens. There we go. We go to lazy bindings, and I forgot to add a column, so it's all printing on top of each other. Please hold. Okay, let's try that again. So we get Mazda 1 printed out each time, meaning it's reusing the same instance. And that is how lazy works. It, as I said, it creates the car instance once only and reuses it. And that might be what you want, but sometimes you might want a new instance each time you call get. And that is what the provider object is for. If the binding is unscoped, like it is in this case, we don't have any scope annotations, it will return a new instance each time you call get. So now when I go here, you can see it is incremented each time. However, this of course still follows the laws of Dagger. So if I make the car a singleton now, it will only have one instance because that's how we have scoped it. So let's just see that to make sure. And there you go. So you have lazy and provider, which are kind of similar but a little bit different in that a lazy will always give you one instance and a provider can give you multiple if it's unscoped. But that's all I've got for lazy. Quite useful and quite good to know about. Now the next one is nullable bindings. And this is a pretty simple topic. Let's have a look. So I'll add a provides method for a house object. And I want to make it nullable, as I mentioned. Now I'm going to do something a little bit different. I'm going to say if random.nextBoolean, return a house object, that's 100 square meters, else we'll return null. So half the time we inject a house, it's going to be null, and the other half, it will actually be an object. Now, as you saw in Kotlin, I made the return type nullable, and in Java, you would annotate it with nullable. Then when I need to use this binding, house, if you try to inject it just like that as a non-nullable type, you will get a compile error. And it just says that house is not nullable, but is being provided by a nullable provides method, which is pretty straightforward and self-explanatory because we've made it nullable. So all you would need to do is make the type nullable as well, and in Java annotate with nullable. However, with Kotlin, you can't have a nullable late in it, so I need to just give it a default value. And I'm going to again add a text label, which just prints out the size of the house, and of course it's nullable, so we'll have to be safe about it. Now, if I try to build this, there's another annoying Kotlin feature that comes into play. So you'll see that it says Dagger does not support injection into private fields. And it's strange because it's not a private field. And this just comes down to what Kotlin compiles to. So you can see that the compiled version that it opened does indeed have a private field. So all that you need to do is annotate it with JVM field, and then you'll be sorted. Note, this will only apply to cases where you have a nullable type here. Otherwise, you can just use late init, and it doesn't apply. Now, when I open up nullable bindings, you'll see this time it was null. If I go back in a few times, hopefully it becomes non-null. Wow, we're not really getting lucky here. There you go. Finally, it was a non-null provision of the house object. So there you go. That's basically nullable injection. It's pretty simple, pretty straightforward. Just unfortunate about that little Kotlin issue. The next thing is optional injection, and despite the name, it is quite different to nullable injection. Let's see what I'm talking about. So I'm going to just add a companion object with another provides method. I'll provide a money object when we're going to pass in 1000 monies. Now, in the activity, as per usual, I will just inject a money object like so. Now, in some cases, you might want to support the use case where this binding is completely missing in your project. This may be the case if you have multiple modules and in some builds you exclude some modules for some reason, but you want the app to still compile and run fine. In that case, you will just have to wrap this thing in an optional. And I will use the Google common one because the Java one needs Java 8. So if your min API is too low, you'll have some tough times there. But I'm just going to wrap this money object in an optional, so Dagger knows that we are catering for it. And finally, in the interface, I will add an abstract method that is binds optional of. Binds optional, again, the name doesn't matter, but the return type will be the money object. And this is telling Dagger to not panic if the binding for money is missing, because we are going to cater for it. So let's just, again, add a text field to show off what we get. And I'm just going to say toString, on that field. Let's build and run and see what happens. Here we go. If I navigate to the optional one, now you'll see it's absent because the binding was commented out. If I add it back in and rerun, we should hopefully not see absent anymore. There you go. We now get an optional of a money object. And of course, you would need to use the optional API here. So you could say, like, if money.isPresent, then you might show the text thing, else maybe you'll show missing, like that. So you would just use the optional methods to determine how you should behave. Pretty straightforward. That's the gist of optional bindings, and you can see it is indeed different to nullable bindings. Now, finally, the last thing I wanted to talk about is multi-bindings. If you remember back to the qualifiers section, you sometimes want to distinguish between multiple cases of the same object. And multi-bindings allows you to get multiple versions of an object. But let's just see what I'm saying here. So again, I'll add a companion object and add a provides method. Now we are working with a game object. So let's just return a new game. That's name is Dota 2. And I will just add a more descriptive name to the method. Now I will add another one that's Apex Legends with a different name, of course. Sometimes you want to have a case like this where you provide multiple instances of the same type. And in the activity, you might want to use it like this. Let's call it games. Maybe you want to get a list of games. And then you could create a column, games.forEach. Then you would again have a text field displaying the name of the game. Right? This is a use case that you might want, and Dagger does indeed support it. The only thing you need to do a bit differently is you need to say provides into set, like so. So what this does is instead of creating a binding of just a game object, it creates a binding of set of games, like so. And it will add each of these elements into that set. Now in the activity, you can inject a set instead of a list. And let's build and run this. But that is basically the simplest way of having a multi-binding, is into a set. There you go. You get both of the names printed out nicely for you. Another alternate syntax for this is, I'm just going to say provide games. You can return a set of games instead of just a single game object. And you would say provides elements into set now, as opposed to just into set. Then you would construct the set object and you would maybe add some games to it, like so, where you can return multiple in one method, like that. Now if I build and run the app, we'll see that we now get all 4 games being printed out. And there you go. Nice. So again, this is the simplest way of having multi-bindings, just a set of objects that you get that you can work on. However, there is a more flexible multi-binding you can use, which is a map. And of course, maps have keys and values. So the value would be your object that you are returning, and the key can be pretty much anything as far as I'm aware. You can make it a string, an integer, a long, or even your own custom keys. But for simplicity, I'm going to stick with string keys. Then when you're iterating over it, you will of course get your key and your value. And I'm just going to set the text to the key, and it points to the name of the game. Now you'll need to change the provides methods a bit. Instead of into set, you say into map. Now you also need to provide the key for the map entry. So I'll say string key. If you remember, I said it should be strings, and it should be a unique value. So I'll just make that one Dota, and I'll copy it to the other method and just give that key apex. So now we have two elements that are going to be added to the map. And that map is injected here, and then we can just iterate over the entries in the map. So let's have a look at how it looks. We'll only get two elements coming back because I deleted the other methods, but there you go. The key is on the left, and it points to the name of the game object. So of course, having a map does give you a bit more flexibility than just getting a set of stuff, but it depends on your use case and what you need it for. For example, now you can say if the map contains some key, then you could do something, or maybe if it doesn't show it, you could show an error, or however you need to handle it in your case. Just gives you a bit extra flexibility compared to a set. I think that's all I wanted to speak about for multi-bindings, if I'm correct. Oh, and by default, say you wanted to inject a map like we have here. If you don't have any elements in it, I will just comment those out. The build will actually fail by default. You can see that it says the map of string to game cannot be provided. And this is probably good because it tells you that the map will just be empty, which is maybe not what you expect. However, if you do want to possibly get an empty map or an empty set, you can add an abstract method that is whatever name, it doesn't matter. But the type must be your multi-binding type, so string to game. And then you just annotate it with multi-binds, like so. Now if I were to run this app, we'll see that we don't have any build issues, but the screen will just be blank because there's nothing in the map. There you go. This is just a way of telling Dagger to not freak out if the map is empty or the set is empty, right? You could do it set as well. You expect it to potentially be empty, so it should just carry on as normal. Cool, and that is pretty much the end of multi-bindings and pretty much the end of what I wanted to show off for Dagger. I know it's been a lot, but I feel that most of this stuff is necessary to know, or at least know about, to have in the back of your mind. Maybe one day you remember, oh, there's this thing about multi-bindings, or having a qualifier, or scoping it to a singleton. I think it's good to know about. Anyway, I've gone on long enough. Thanks for watching. I hope you've enjoyed, and I hope I've helped you to learn something. I'm always keen for feedback, so please do let me know what you thought. Thanks for watching, hope you've enjoyed, and cheers for now.